Assalamualaikum and hi, we are from Group 5 Section 1. Today we will present our Pbl Activity 1, which is about noise, Chapter 2. My name is Nur Izzati binti Omar, CE10111, and this is my group members, Hilmi Haziq, Nurul Ismahani, Navin, Muhammad Akmal and Rishita Ren. For our report project, firstly, we will present about the introduction, which is contain problem statement and our objective to solve the problem. Second is the brainstorming process that we will explain by using filler table and flowchart. Next, my group's member will be explain more about solution 1 and 2. Lastly, the conclusion from the Pbl Activity 1.
My part, which is introduction for the first PBL that we conduct as a group project. So the intro is the signal noise ratio of SNR is defined as a ratio between the desired information or single power and also undesirable signal or background noise power. So the signal noise ratio is also scientifically and also technically measurement parameter that compares the level of the desired signal to the amount of background noise. And also, in other terms, SNR is the ratio of the signal to noise power, which decibels as the standard unit of the measurement is dB. So we call it dB. And also furthermore, a signal to noise is larger than 0 dB or greater than 1:1 indicates that there is a more signal noise than the noise. So the higher number generally mean the better specification, since they are more useful informational than unwanted data. So many goods that deal with the audio, such as speakers. Secondly, the problem statement. So the problem is to identify and also analyze a solution to produce the higher signal to noise ratio (SNR) output of the communication system, and moreover, considering our own values of amplifier and also chambers to increase the output signal of the noise ratio. So the objective of this project is to calculate the highest output of the signal noise ratio. That's the first thing. Then the second one is to learn more about the basic calculation of SNR and also SNR system, and also brainstorming the technical and also the non-technical solutions for the also to calculate the highest output of the SNR value, and also understand the given receiver system design parameters and also the limitation. For example, we have to understand about the amplifiers and also understand about the chambers.
For the filler table, we list about 5 facts about this noise topic. So the first one is electronic noise. The idea is we use a filter to reduce noise. For example, lock-in amplifier can extract a narrow bandwidth signal. The action is we using a low noise amplifier. The second one is reduce the noise and improve the signal to noise ratio. By using the narrow bandwidth, we can reduce the noise and improve the signal to noise ratio. The third one is the arrangement of amplifier. The idea is to produce the lowest noise factor. So by produce the lowest noise factor, we have to arrange the amplifier that produce the minimum total noise factor. The lowest total noise factor produced, the higher signal can be achieved. Fourth one is the higher the ratio, the better the signal quality. So we can take precautions to reduce noise generation. The incoming signal is strong and well above the noise floor. The audio will be maintained a higher quality. We can adopt the antenna arrays by exploring the redundancy across the multiple transmit and receive channels. So for the last fact is resolve the noise impairment problem by proposing the best solution with the highest signal to noise level. To get the signal to noise ratio, subtract the noise value from the signal strength value to find the quantifiable difference between intended signal strength and the unwanted noise, we can use the mathematical formula, which is S over N equal to P S over Pn. For the flow chart, first one, we need to finding the total noise using Frisch formula. Next, we can find the noise power based on temperature given in the question. Next, we can find the signal to noise ratio input and output, and then we can rearrange the amplifiers to produce the highest signal to noise ratio. For the second question, we need to propose the other ideas to enhance the signal to noise ratio. So we have proposed 3 ideas, which is using a regenerative circuit. Second one is improving the signal strength, and last one is shifting the signal to another frequency band.
So in this question, we must find the arrangement of the amplifier to find the signal to noise ratio with the highest output. Okay, so the specification of chamber are: chamber 1 has the initial temperature of 77 degrees Celsius, while chamber 2, the initial temperature is 300 Kelvin, and chamber 3 is 415 Kelvins. So not only that, we also given another information that tell us that the input signal power is 5 watt, the bandwidth is 400 megahertz, and the temperature of the environment is 308 Kelvin. So in each amplifier, the gain amplifier number 1 has a gain of 4 dB and 2.51 in unitless unit. Amplifier number 2 has the gain of 5 dB and the gain in unitless is 3.16, while amplifier number 3 is given in unitless, which is 20 unitless. Okay. So the first step that we need to take before we also find the highest output of signal to noise ratio is, firstly, we must find the noise figure for number 1, 2 and 3 by using the formula Fn is equal to 1 plus environmental temperature over the reference temperature. So as you can see, the reference temperature is 290, while the temperature environment is depend on the temperature of each chamber. So as you can see, this is the noise figure for each chamber, okay, which is 2.2069 for chamber number 1, chamber number 2 2.0345, while chamber number 3 is 2.5517. Okay, next we must use the Frisch formula to find the total noise figure of the cascade for amplifier. As you can see, the F total is equal to F1 plus with the F2 minus 1 over gain of amplifier number 1 plus with the F3 minus 1 over the multiplication of amplifier number 1 and amplifier number 2. So as you can see, there is a 6 type of arrangement for the amplifier that we can use, which is such as 123 or 213 or 321. So as you can see, this is the total of the noise figure or the cascade amplifier based on the arrangement of the amplifier. Okay, and then after we find the total noise figure for the cascade amplifier, we must use the formula. We must use the Frisch formula again to find the environmental temperature for each chamber and amplifier. Okay, as you can see, we have the environmental temperature is equal to temperature of chamber number 1 plus with the temperature of chamber number 2 over gain of amplifier number 1, and the temperature of chamber number 3 over the multiplication of gain of chamber number 1 and chamber number 2. Okay, so as you can see, the temperature is based on the chamber, while the gain is changing depending on the arrangement of the amplifier. Okay. Then after we find the temperature of the environmental temperature on the cascade amplifier, we can use the Pn is equal to K bracket T plus T environmental T bracket times with the B, which is the bandwidth. Okay, to find the input noise power. Okay, can see the calculation, and then we get the answer in what unit. And then for number 5, we can find the signal to noise ratio for the input by using the formula PS over Pn. So as we know, the PS is the input signal power, while the Pn is the input noise power. Okay, so after we find the input noise power for each arrangement of the chamber, then as we know, we have find the F. So we can use it. We can rearrange the formula from F, which is the noise figure, is equal to SNR input over SNR output. So we arrange it to find the output, and then we can find it by dividing the SNR input with the noise figure, with the total noise figure. Okay. So as you can see, this is the calculation to find the signal to noise ratio output. So as you can see, the highest output. So based on the calculation of the output SNR, we can conclude that the suitable sequence for the cascade amplifier with the signal power of 5 W and the bandwidth of 400 MHz is amplifier number 1 first, and then we use amplifier number 2, and lastly we put the amplifier number 1. So the output, as you can see, is 4.969 times with the 10 power of 11 in doesn't have any unit. So for the dB, we can find the SNR output by 10 times with the log 10, 4.969 times 10 power of 11. So we can get SNR output is 116 and 963 dB. Okay, so that's all for me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
My name is Navin. Now I'm going to present about present question 2. So the question for question 2 is, without considering the mentioned condition and limitations, what could you propose to further enhance the output SNR? So the first point is using a regenerative circuit. To boost your SNR is to use a regenerative or Q multiplier circuit. Active filter with a positive feedback is used in this technique. This positive feedback has two effects which reduce any noise in the circuit while also boosting the weak signal. Next, improving the signal strength. The noise effect is minimized by increasing the signal strength. It's important to understand that when increasing signal strength, we are talking about the signal before the transmission. So when a signal is amplified before transmission, it is less vulnerable to attenuation and distortion. So the third point is level shifting. Another excellent way to improve SNR is to level shifting method. To shift the signal to another frequency band, this method uses a local shifter and frequency mixer. This includes mixing the frequency of the original signal with the frequency of local oscillator to create a signal that falls within this frequency range. So the next point is install a cooling fan. Cooling fan is important to increase the airflow inside the amplifier. This will keep the amplifier cool and improve the performance of the amplifier. By using cooling fan, can speed up and prevent the amplifier to heat up and function properly. Last point is install a soundproof. To stop external noise out of the chamber and internal sound inside the chamber, we can fix a soundproof inside the chamber. It's hard to prevent all the sound waves out of the chamber, but fixing the soundproof can reduce the amount of the sound get in and out of the chamber. That's all from me. Thank you.
Assalamualaikum and hi, my name is Nur Ismahani binti Muhammad Jaswadi and my matrix number is AE10028. For the next, I will continue to present for the conclusion. In the conclusion, based on the learning assessment and knowledge that were practiced in the class, students were able to finish this SNR project successfully. The highest signal to noise ratio output of the communication system was successfully produced. Better signal quality can be achieved if we using the higher ratio of antenna adoptions array by exploring redundancy across the multiple transmit and receive signal. The signal-noise ratio output can be calculated by using mathematical equation, which is SNR output equal to SNR input over the F, which is F represent the total noise figure. As you can see in result of activity 1, the SNR output we get is 116.963 in dB with the limitation given. But if the limitation doesn't have any limitation, then we also can get the highest signal noise ratio, which is by installing the cooling fan or installing the soundproof and level shifting. Signal noise ratio is really important in our daily life as it will apply in most of the electronic devices such as laptop, telephone, radio, and television. This electronic device audio can keep higher as long as the signal strong and well above the noise floor, which is the type of signal to noise favor for the clear and accurate sound. So that's all from me. Thank you.
And lastly, for complex engineering problem CEP identification form, the question is, what is the new knowledge you have learned from this PBL assignment? The new knowledge that we have learned from this PBL assignment is a deep understanding of electrical noise in Chapter 2 to solve the challenging problem of communication system noise impairment by giving a variety of technical specification and limitation for analog receiver amplifier and chambers. Other than that, we learned to analyze the resulting signal-to-noise ratio (SNR) characteristic and propose a method to lessen the receiver system noise. Impairment. Lastly, we can propose the best solution with the highest SNR level to tackle noise impairment problem. Second, in your opinion, what is the most complex issue in completing the given task? In our opinion, the most complex issue in completing the given task is to find and study a solution that will give the communication system the maximum signal-to-noise ratio (SNR) output, and we need to have a piece of deep knowledge and understanding for this specific chapter, electrical noise, to come out with the best solution. Lastly, how did your group come up with the idea of the best possible solution to the given complex problem? For our group, the idea of the best possible solution to solve the challenging problem of communication system noise impairment that give a variety of technical specification and limitation for analog receiver amplifier and chamber are from group discussion and brainstorming to get the effective solution for this PBL assignment. That's all from our group. Thank you.